Hi, this is Alex from devstories.eu, Docker Masterclass, Episode 3 of 18. You deploy an application and it works perfectly. 2 weeks later, you restart the exact same application on the same machine and it crashes because a system library updated itself in the background. That silent environmental drift is exactly what we eliminate by understanding the anatomy of a Docker image. First, clear up the most common point of confusion. An image is not a container. An image is a static template. It contains your application code, your libraries, your system tools, and your runtime. A container is simply a running instance of that image. You can start 1,000 containers from one image, but the image itself just sits on disk waiting to be read. The defining characteristic of a Docker image is immutability. Once an image is created, it is never modified. You cannot change a configuration file inside an existing image. If you want to change an image, you must build a completely new one. This immutability guarantees that an image tested on your laptop behaves identically in production. The template cannot drift over time. If you cannot modify an image, you must construct new ones. A Docker image is not a single massive file. It is a composition of multiple independent layers stacked on top of each other. Each layer represents a specific set of file system changes, which means adding, modifying, or removing files. Consider a Node.js application. You rarely build the operating system yourself. Instead, you start with a base image. This base image contains a minimal Linux distribution and the Node runtime. That base is actually made of its own layers, but to you, it acts as the foundation. When you add your application to this foundation, Docker records your changes as new layers stacked on top. First, you bring in your dependency configuration file. That creates a new layer. Next, you instruct the system to download and install your dependencies. All those downloaded libraries are packaged into the next layer. Finally, you copy your application source code. That forms the top layer. When you start a container, Docker stacks these layers using a union file system. This makes all the independent layers look like one standard directory structure. If the exact same file path exists in two layers, the version in the upper layer hides the version in the lower layer. Here is the key insight. Because layers are immutable, they are heavily cached and shared. If you update your application source code and build a new image, Docker calculates what changed. It sees that the base Linux image, the node runtime, and your dependency layer are identical to the previous build. It reuses those existing layers instantly and only creates a new layer for your updated code. This turns a deployment that could take minutes into an operation taking milliseconds. This architecture also saves disk space and network bandwidth. When you push your new image to a server, you only transmit the single layer containing the new source code. The server already has the base layers. By enforcing immutable layers, Docker guarantees that your application environment cannot silently change, while ensuring you only ever transmit or store the exact bytes you modified. That's your lot for this one. Catch you next time.